another lecture of quantum mechanics. Now we learned that that any acceptable wave function can be normalized by multiplying it by an appropriate constant. Alright, so this is the important point to remember. Alright, so acceptable, we'll come to that. What is acceptable meant by acceptable? Like we'll discuss it. But let's start with an example first. Let's see, like if you have a wave function which is given by sine pi x by L, okay, where x lies between 0 and L. Okay, L is a constant, this is a constant, some positive constant. And if you integrate this quantity, now this is a real function, right? If you take a mod square, you'll just square the function. So be careful. This is a real function, so we are directly squaring it. You cannot square it every time if it's a directly square it if it's a complex function. So what you need to do is you integrate this thing. So if you integrate this thing, what you can write? You just convert it using the trigonometric function equation we know. So this will be 2 pi x by L dx is equal to, this is 1 by 2. So if you integrate this, you will get x minus, this is L by 2 pi. Now this will give you sine 2 pi x by L. Now this is 0 to L. So if you calculate it, if you see it, so what you'll get is simply L by 2. Alright, I'm not doing it, it's a very easy calculation. Just put the upper limit and the lower limit. Okay, everybody should be able to do it. You should pause the video and just calculate this, okay, and check whether it matches this result. Now this quantity is some finite quantity. This is not equal to 1, right? So we say that whenever this is not equal to 1, this integration is not overall space. In that case, we had minus infinity to plus infinity, since the wave function could have been in the whole extent, but in the whole region. But in this thing, the wave function is limited to this. It is 0 otherwise. Okay, so we'll learn about this. This wave function comes for 1D box. Okay, so we'll learn about it. But in this, we are using it as an example. So it's not normalized. So what we do? We assume that we assume a psi, which is psi on, and we say that this normalized wave, we multiply a constant, which is known as the normalization constant, and we multiply by pi x by L. Okay, so we say that this is a normalization constant. Okay, so if we do this integration to check, it should be the, like if you apply the normalization condition, which is psi mod square 0 to L. Okay, so you just directly write it down. Okay, this is pi x by L dx is equal to 1. Now we know this integration, we have already calculated it. This is this value. Okay, so we write a square L by 2 is equal to 1. Now this is a is equal to root 2 by L. Now if you multiply this quantity, this is called a normalization constant. See, this has plus as well as minus. We prefer to take positive here. We'll talk about why we didn't take minus. We could have taken minus also, it's the same thing. Just that the wave function will be flipped. Okay, so let's take the positive one and write it down. So this is this wave function is a normalized because it will satisfy this condition. Okay, that we know the normalization condition is for this quantity is this is dx equal to 1. So this will satisfy this. Okay, so this is normalized wave function. normalized side. Okay, so the first thing, whenever you have been given a wave function, first you need to check is whether it is normalized or not. Okay, then you can proceed with the other calculations. All right. If you find these lectures useful, then please like, subscribe, and share with your friends.